Hello student, welcome all of you. This is my lecture number 9 of the topic surface chemistry for class 12. This is a continuous lecture from previous lecture 8. In earlier lecture we have discussed about the enzyme catalyzed reaction. Now we have to discuss what are the characteristics of enzyme catalyzed reaction. First characteristics, enzyme catalyzed reactions are highly specific in nature. It means for desired product we have introduced the specific catalyst. It means for a specific desired product it requires a specific catalyst. Let us take example urea. General formula of urea NH2CO NH2. Urea which undergoes decompose in presence of urease. Urease is a specific catalyst. Urease, then it converts into ammonia and carbon dioxide. Similarly, lactose, the general formula is C6H12 C12 H22 O11. This is the lactose. General formula, this is the lactose in presence of lactase enzyme. Then it converts into beta D-glucose C6H12O6. And beta D lactose. This is the first characteristics of this one. Now we have to discuss second characteristics of enzyme catalyzed reactions. The enzyme catalyzed reactions are highly efficient in nature. It means a small concentration, that is the amount of enzyme, the reaction becomes fastens due to there is a strong enough regeneration capacity of enzyme. Capacity of enzymes. So, enzyme catalyzed reaction is highly efficient in nature. Now, third point we would like to discuss all enzymatic reactions which takes place at minimum optimum temperature as well as pH value. The all enzymatic catalyzed reaction takes place at minimum optimum pH is nearly about 7.4 and particular temperature, that is 298 Kelvin. Next point we have to discuss the enzyme contains certain coenzyme which helps to increase the activity of enzyme such as Na plus, CO2 plus, etc. The next point we discuss about the characteristics of enzyme catalyzed reactions, that is the enzyme which contains inhibitor or poison which slow down the enzyme catalyzed reactions. The inhibitor which binds the active site of the functional group of substrate, that is the reactant, which destroy the activity of substrate. These are the characteristics of enzyme catalyzed reaction. Now I would like to discuss about the mechanism of enzyme catalyzed reactions by help of lock and key method. Mechanism of, now we have to discuss mechanism of enzyme catalyzed reaction by lock, key method. First of all, this is the enzyme. Enzyme which behave as a catalyst. Simply, it behave as a catalyst. This is the enzyme. This one is a substrate. This one is substrate. First of all, enzyme and substrate. Substrate is organic reactant. This is the biochemical reactions. Organic reactant molecules which are known as substrate. First of all, it combined with enzyme substrate complex. Then the chemical reaction takes place and it forms, convert into convert into enzyme product molecules. Then upon deoxidation takes place. Let us take this one is substrate, and then lastly is D. Then lastly it convert into enzyme as a simply behave as a catalyst. So it remove from the active site of this enzymatic reactions and product is to be formed. This is the product. So this is the enzyme. This is the method the reaction takes place of enzymatic reaction. Now we have to discuss the other topic about the surface chemistry, that is a colloidal chemistry. Colloids science. Colloids is a state of matters in which its particle of the size intermediate in between suspension and solutions, true solutions. Colloids is a state of matter in which its size of the particles in the form of colloidal range, that is 10 to power minus 6 meter to 10 to power minus 9 meter. It means it is intermediate size of particles in between suspension and true solutions. gum, example is gum, gelatin, starch, etc. These particles radially dissolve into water. So that colloidal solution is heterogeneous mixture. Now we would like to discuss the difference between, what are the difference between suspension, colloids and true solutions. Now we would like to discuss distinction